Here we are see what we have done in your project. First of all, we designed one build in with the help of SolidWorks Creo or whatever the design tool we used. Okay, then we used calculations. Okay, this is the calculations for weight of your object. Like these are the calculations which I have taken from the some assumptions and based on some like real-time dimensions, and so many calculations are there. So based on that, I have made some calculations like this, and we made like this, like different kind of load conditions, like 3 members. What if there is 3 members? What if there are 5 members, 7 members, 9 members? So different kind of dimensions. Dimension is nothing but like weightage we have considered, and we have taken the value as maximum velocity is 150 kilometers per hour. Okay, and the radius is okay, when you convert this into the radius per second, you have got this 182 per radians per second, and these are the dimensions which you have designed your object. So this is your object. Based on these dimensions you have developed, I have given this step-by-step formation. First you have to create one circle like this with the outer diameter of 458, then you have to do it like this with a extrusion. This is extrusion option, and here you have mentioned 178 mm thickness is nothing but extrusion length. Okay, and you have made like this, then you converted like this with the help of revolve cut, and then you have created a wheel rim like this. Like these are the spokes. Okay, after creating this pattern and everything, you have made like this. Then this is your final object, like final output. Then after you have chosen metal properties like aluminum 6082 and aluminum lithium alloys. Then now we have entered aluminum properties here and aluminum lithium properties here. And meshing is nothing but like you have creating your object into small particles, so that you can travel, like whenever you apply any kind of load on this area, it will travel throughout the object. Like if you particular suppose in this area also you have applied any area, any load, it will travel like this. That means each and every object will connected to another, each and every element. Okay, so that is what mentioned here. Then you have applied load on this area. Okay, these struts are fixed with the fixed support, and you have applied load on this, and this load value already calculated in above calculations. Okay, for 3 members you have got this much of load, and then you have calculated results for aluminum 6082 and deformation values as given. And here you have red color is the maximum deformation, blue color is the minimum deformation, and same kind of values like stress and everything. Like red color indicates the highest value, blue color is the lowest value. Same strain, safety factor. You have to remember one thing, based on safety factor values we are deciding this load is allowable or not. See, according to the design consideration, the factor of safety should be greater than 1.5. You have to remember this. If the factor of safety value is greater than 1.5, the allowed, whatever the load you have applied on the object, it is considered as a allowed load. Okay, here you have minimum value is 2 point something is there. I have mentioned here say 2.02. so this is greater than 1.5, right? So if you have 1.5 greater than factor of safety minimum value, so your object is allowed to that load. When you changing this aluminum lithium, and you have got these results, and now we both combine these results with the tables and by manually, and here you have got this 1 point. Okay, by using this material the deformation changes there, so the deformation value is reduced, and strength, okay, stress value is almost similar, but the strength has been increased here, okay, compared to this, and this is having good strength values. And when you using these tables, like you will get graphs like this, and these are graphs like made up of Excel sheet only. Okay, so these are graphs are drawn by manually. Okay, by entering these values in Excel sheet you will get these graphs. By looking at that graph you will get to know like what you have done and what you have got. Okay, and then next same process repeated for the 5 members also, and 5 members loads he has given like 26,400 newtons. This is what okay, this is the load, same. And next similar conditions, like you change both materials, then both the results you have been entered here. Okay, and finally you showing all the results for 7 members and for 9 members. Okay, and for all the results, like I'll show you this in one single table, like you'll get to know easily, like you can understand easily. See, each table has their conditions like 3 members, 5 members, 7 members, and 9 members. See, when you look at the highest condition, maximum safety factor is minimum safety factor is 1.92. So this is the maximum load conditions which we have applied till now. So this is the maximum capacity. So in maximum capacity also you have greater than 1.5. So your design is safe at this condition also. So you can consider this design is allowed 9 members on it. Okay. So based on these values, and you wrote like deformation, stress, and strain, what you understand based on the tables and everything. Then again you calculating natural frequency. Natural frequency is nothing but you calculating the inbuilt frequency values. It's nothing but every body has their own frequency values in each direction. Like every object has 6 degrees of freedom, DOF we call it as. So 6 degrees of freedom in each DOF has their own DOF natural frequency values. So here it is mode 1, mode 2, mode 3, mode 4, mode 5, mode 6. So each degrees of freedom is calculated each natural frequency. These are the natural frequency values. Okay, if the natural frequency values is high, okay, that means it can withstand more vibration. You have to remember this. If the frequency values, natural frequency is nothing but natural strength of your object. That means there is a maximum withstand capacity of your vibration. Just remember this. Okay, if the natural frequency values are high for any object, like, okay, then metal is considered to be the strongest compared to the other material. Because see, just imagine, suppose you know that resonance factor, right? Resonance is nothing but when the natural frequency when the force of vibration will meet the natural frequency, then there is a collapsion. Okay, we call it as a resonance. Suppose you understand that if the march for soldiers will do like kawatu like that, okay, on the bridges, there is a chance to collapse that bridge, right? So we call it as a resonance. So that's the reason that if they see they do it ironically, significantly they do that one at a time, right? Suppose if 100 members are doing same kind of steps in a single fraction of second, okay, it may chance to lead the frequency of the bridge, that force vibration. So the bridge going to be collapsed. So the similar way, okay, if at all any vibration occurred on your wheel rim, the first meter, the first frequency will reach for this material, right? Once 265 reaches vibration, then only it will reach us this, right? So first will break this. That means the first damage occurred for this material, and it withstand larger than this. So aluminum lithium is compared to the 6082, it is having much more strength in a dynamic analysis. So finally you're giving that conclusion like that, and your object is having different conditions on it, 3, 5, 7, 9 numbers conditions, and it withstand same condition, each and every condition it withstand. Okay, it is safe, but aluminum lithium is lithium metal, it is also good at in vibrating conditions like dynamic analysis also. So finally you're giving that conclusion this is the best one compared to other. Okay, and I'm giving this open ending, by telling this, you're not giving that particular one idea, you're just mentioning that which is best and why it is best, and what is the capacity of other material also. See, you cannot deny that this is not better, you cannot deny that, because this is also has good results. Okay, so there is a similar, there is a possibilities are there, there is different situations will be there for each material. So that's the reason you are not giving any particular one conclusion, but you are giving that process, we have done like this, we got results like this. So among this, I have got better results for this, and giving finally based on your results, and you giving one conclusion like that. So that's it, what you have done in your work. I hope you have got each and everything what you have done. And okay, thank you, bye.